Okay, so now I'm going to be testing whether a fluorescent light bulb here will respond in any manner to this modification of the Meyer voltage intensification circuit. And like I said before, the only modification is that the second wire on my bifilar coil has one end of it free floating. Okay. Another thing I did was ground this connection here between the water fuel cell and the secondary on my transformer. So there's a ground on one side, free floating on the other side. Now I already did this experiment, so I know where the interesting point to hook up is. And that'll be right here onto this free floating wire. Turn on my signal generator, and it's already pre-tuned. There we go. And you can see sort of the bubbles coming out of there. Anyway, so now I've got this thing here hooked up to the formerly free floating end of this bifilar coil. So turn off the light, and I'll touch this end here. Ta-da! It lights up. And I can extend this by maintaining a connection and ionizing the gases in there sequentially until I get to the end. Then I can grab it, and voila! It lights up. So the next question is the energy merely flowing out of there, going through here into my arm, and down to the ground? Well, I'm going to be jumping up into the air and testing whether the bulb stays lit. So here I go, I'm going to jump. And the bulb stayed lit, so therefore I'm functioning more as an antenna than just a direct ground into the floor. Next, I'm going to show that it's actually a capacitive coupling. Put my hand very slightly near the bulb, and even though it's not touching, you can see that it's lighting up. See? So there we go. And of course, the other interesting point in the circuit was over here on the initial output of the secondary. If I connect that, the bulb is very light, very bright. And there you go.